I'm Mike, CEO, co-founder of Quix, and I'm here again with my buddy Patrico. We had a lot of fun last time, Patrick. We called it internally the Mike and Patrick Show. So,
Yes.
Let's see what sort of trouble we can get up to this time.
Yeah. Should I do my presentation as well? I did a very long one the last time, but maybe I could do it shorter.
No, you don't need to introduce yourself. Our community, our YouTubers, the audience, they know who you are by now. And I'm sorry for the background noise. I'm in a co-workspace. I don't know if you can hear that, but it's part and parcel of this new way of working. No, you can't hear anything.
Yeah, no, it's good.
That's good. Yeah. Cool. Well, last time out, me and you spoke about our backstory, and then there was a session with Steve and Peter talking about the SDK. But this time, you and I are going to get under the hood and talk a little bit about what happens inside Quix with the APIs, right?
Yes, exactly. So, do you want me to speak about the architecture, general architecture? I have prepared I have prepared some slides where we can discuss on top of that if you want.
Chuck it on the screen, Patrick. Let's have a look.
Yeah, I'm going to share the screen. I think this screen. Good. You see my screen?
Yeah, I see it. Yeah.
Cool. So.
Well, there's a lot going on here. So talk us through the overall architecture to start off with.
Yeah, so I'm going to start explaining a bit the concept of our platform, because people probably don't know, or maybe some people is new and don't know what we are talking about. But we have a concept that is a workspace. And what is a workspace? A workspace is like a infrastructure bundle of where you deploy your real-time pipeline, the data processing pipeline. Mm-hmm. And in this pipeline, we have deployments, that is each application that is processing this data. Mm-hmm. And we have topics, that is the communication between these processes. When we say topics, they are a Kafka topic. That is our main message broker. We are using Kafka as a main way of communication between each step of your pipeline. Yeah. So these are represent the Kafka topics, the Kafka broker, but I represent it with arrows because it's easy to understand for people.
Because data always flows from left to right, apparently. That's what I've been told this week. Data always flows from left to right.
Yes, this could be more complicated, but just to make it simpler, for example, I make just 3 deployments and 4 arrows, but it could be very, very complex pipeline. Okay.
So deployment is where we're processing data with our code, and the topic is where the data is flowing into or out of our processing, correct?
Exactly. And it's starting from the left side and it's going out from the right side.
Always.
So this is happening inside the workspace, but what happens when you want to gather information or get some source of data from outside Quix, outside our platform, outside the workspace? And is where we are providing some APIs to the external world, allowed to introduce data inside of this pipeline. The same happens in the right side. That is when you are putting data out of your workspace, your Quix workspace, to the external world as well.
Okay. So I noticed on the left-hand side here, we have a streaming writer API, which is, I guess, a producer API. In the pub sub world and streaming world, sometimes they're called producers. So this is writing equals producing, right? We can send data to a Quix workspace.
Yes. It's the same concept that you have in one deployment, but in a generic pipeline. The same concept of input output when you're doing a deployment, but in a whole workspace. You have the input, that is a streaming writer API, and you have the output, that is a streaming reader API, but speaking with external world, with external systems, external person or dashboard or whatever.
If you can draw, right? I'm going to put you under the
pressure.
Yes.
You can draw. I can draw.
If we draw a little client device somewhere down here on the bottom of the screen,
Yeah. Well, I have a surprise, I think, for you, because I have another slide already. Already prepared.
You've been busy. Okay.
Yes.
How do you have time amongst your day job?
I don't know. I'm working too much hours, I think. So basically this is the concept. So you have a lot of devices in the left side writing data or trying to write data to the inside of this workspace. And when I mean a lot, it could be infinite devices. And this is the main concept of creating these APIs, because Kafka, so these topics that we are here, Kafka on itself is not very good prepared to handle a lot of connections. Mm-hmm. So you cannot connect thousands of millions of devices to Kafka topics.
Okay.
So it's not because it's a bad technology. It's because it's not designed to be a hub to handle all these connections. It's designed just to communicate messages from one microservice to the other. And it's it's what we are using.
It's a backend microservice technology. So you don't end up with millions of microservices, right?
Exactly. And it's very good. It's a very powerful technology that can handle a lot of data per second, but it's not good handling a lot of connections. And it's the reason because you need something like a proxy service to handle these connections and convert all these connections in only one connection.
So hold on. So the streaming writer, let's start on the left-hand side. This is actually a service.
Yes.
There's some service which is deployed with the workspace, and it lets you connect. It lets you connect client devices at scale, and then it converts that into the Quix SDK format and sends that into a topic. Correct.
So here we are speaking with the SDK format.
Yeah.
So this is SDK format. Mm-hmm. So what we are doing in this API is converting this HTTP. You can use web HTTP or WebSockets. So WebSockets is a bit more efficient, but HTTP is more supported for any language. You can use any language to use this API, and we are converting this to SDK format. And from that point, the pipeline is working with the SDK format.
And what data can you write to the streaming writer API?
Well, any format that the SDK supports. That basically is time series data that could be events, so just a JSON event or some specific irregular based event. But when you have a regular based data like telemetry data, so something like the speed of a car or the revolutions of your washing machine, for instance, it's when you are sending 10,000 values per second is just regular data, and we are quite efficient sending this type of data. So it's these two type of data. It's like metrics, or we call it parameters, but just to people to understand, it's like metrics or events. Okay.
Yeah. Okay. So events is obviously a JSON payload, and a metric is some scalar value, some numerical
scalar values.
Constantly changing scalar value, I suppose.
Correct. And events is like something more irregular. So it's not something that you are receiving in a regular interval. It's something more irregular.
Patrick, we have some developers sending some binary data. There's audio files and video files. Are they using this service as well?
Yeah, exactly. So our SDK supports binary. So it supports numbers, strings, or binary data. So you can send any of them with our APIs as well. Okay. So, and you were mentioning that we have this here. And it's worth to mention that when you create a workspace in Quix, we are creating these APIs for each workspace. So all of them are independent of each other. So if you have, for instance, a developer environment or developer workspace, and you have another that is production workspace, you can be sure that your development workspace is not going to be affected in terms of performance with your production one. Yeah. So we are creating these services out of box each time that you create a new workspace.
Okay, very cool. So data comes in, data gets processed. You build some pipeline cleaning, maybe some feature engineering, maybe you deploy a machine learning model. At the end, you have some predictions, some results, and then we can write them using the streaming reader. You can get them out of Quix somewhere else, right?
Yes. Yeah. So, and this is normally when you want to consume something in real time, because what we are talking here is basically always real-time data, okay?
Yeah.
So when you have some need to see this data in your screen, for instance, in real time, some dashboard in real time, or you have some system that should automatize some alert or something to happen very fast and react very fast.
Yeah.
You want to use this streaming reader API. So you want to react fast, and you send this information outside the workspace. So it is when you use it.
I mean, Formula One race engineers, they sit there looking at live data all day long. But I think the real value for this is automation, right? So you can actually, you can drive another system using some real-time automation inside Quix.
Yes. I have another slide for that.
Oh, in this sense, I want you to draw me a special arrow.
Yeah.
From the streaming reader, can you draw an arrow all the way back round to those mobile phones for me?
So from the streaming reader to the mobile phones.
Yeah, all the way back round.
Yeah, of course you can. You can. Yeah.
Because I think for me, this is what I see as the big opportunity. Many developers are trying to figure out how do we send data from many devices to the cloud. We do some machine learning model, like the Uber surge pricing thing, right? When I'm booking my Uber, I can get a price, and that price is dependent on how many other people are booking and how many cars are available, drivers. And you can get that result back to the client device very quickly with Quix. And this, I think, is really where the next generation of data is happening. It's actually automating systems in the user experience.
Yeah. So you can do it. Actually, I think that we have done some projects around this architecture. You can do so many arrows. So you can go to another place and go to another arrow. You can go to another workspace again, Quix, and go then to the device. Yes.
More arrows, the better. Cool, man. So we get it. So we can have a live data flow from the client. You can process the data in milliseconds. You can get that data out and do something with it, automate some system. I notice here, so the big fat elephant in the room for a streaming company, there's a storage. What is this persisted ? Storage? Tell me a little bit about that.
Yeah, so in our platform, we have a feature that you can, with a very easy user interface, to say, I want to persist this topic in data, this real-time data that is happening in real time. I want to persist it in some data storage to query later this data in historical base. So this system is to process data in real time, but sometimes you want to see what happened in the past, what happened yesterday, what happened 1 hour ago. Okay. And what we are doing is we have a switch in the UI. I want to store this topic in the database, and we have a data explorer to explore this data with the UI. And this UI is actually using this API that is here drawn in the green. So this API is used by this API is used by this UI in our platform, but is another API that our users can use as well for their own implementations. You don't need to just use our UI. You can create your own applications and query historical data from this workspace, and is what we are providing here in the green box.
Okay, so essentially a developer can configure their storage, and then we have, I mean, just for reference, there's also a service here we call internally the Telemetry Writer, but it's not exposed, right? There's a box that sits here in between the storage and the live pipeline, right?
Yes, here you have a Telemetry Writer. I haven't drawn here in this architecture because I wanted to be simplified for the audience. But yes, we have
the Telemetry Writer for me is a discussion of another whole Patrick and Mike show because there's magic in the Telemetry Writer. So you can write off data into the storage and then query that later, and obviously that gives you the ability to sort of close the gap between streaming and batch processing, correct?
Yes, and the beauty of to create this API is that this API is an abstraction layer on top of this data storage, because it allows us to change these technologies that we are using to store the data. That actually we are using 3 databases, but if in the future we want to change one of them because it's outdated, or if something new happened in the world, because it's very common that next year we have a better technology, we can use it without changing this API. So our clients, our users, are not affected for this improvement, and it allows us to improve these technologies, but the user doesn't need to worry about it.
But what if I'm a sophisticated user and I want to put my own storage there? Are you going to let me do that in the future?
Yeah, actually, we are not allowing that, but we have in the roadmap something called, I can say the name that we are calling it. Yeah, I think so. So we are going to implement something called Octopus Architecture. So what we are going to allow to select different parts of the infrastructure from your own infrastructure. So you will be able to select your own database, or your own Kubernetes cluster, or your own Kafka. And one of them is use your own database. And this was one of the features that we want to provide in the future.
Cool. And so then we have a query API, and so you can access the data in this storage that's been put there through the Telemetry Writer. And essentially, what does that let you do, this query API?
Sorry, again? So
what does it let you do, this query API? It lets you just query historical data.
Yeah, it's querying the historical data.
Mm-hmm.
Yeah, so if you have an application that instead of have a dashboard that is in real time, you want to query data of another dashboard or some table or whatever, the visualization is the less important. But if you need query this historical data, you can query this, use this API. That, by the way, we are providing out of the box in our platform, the script and the code to copy paste to your application directly. So you don't need to write this code yourself. We are providing some templates, auto-generated templates to query this data. So the same data that you are visualizing in our platform, you can press a button and have the code snippet.
So you can get the code, you can basically access that data in your Jupyter Notebook or something. And
yes, you can. Yeah, exactly. You can use your Jupyter Notebook to copy paste from a Python code and start working with the historical data in your Jupyter Notebook. Yes.
Oh, very cool. That starts the training workflow. Very nice. Good. And then the top up here, we've got Portal API. What's this? We haven't talked about a portal yet. What's Portal API?
Yes, this is not an API that we are deploying in a workspace directly, but I painted here because it's something that is available across all workspaces. So this is basically the API we are using as our backend. And so our frontend is speaking with this backend Portal API. And basically, it's something that as a user, you can use if you want as well. So basically, it will allow you to create topics or create a new deployment, start and stop deployment, or persist this data. So everything that is related with all this infrastructure that you see with the arrows and the boxes, the Portal API allow you to operate this. So actually, we are thinking to even improve this way how we are deploying things. So in the near future or in the roadmap, we are going to implement some new features to make it even more easier to deploy a whole pipeline. But yes, it's something that we are still discussing.
Very cool. Very cool. So all in all, we have got a complete suite of APIs around core product here, and it lets you really create whatever you want to create.
Yeah. So, sorry. Can you repeat the question? I didn't realize that it was a question.
So I'm not sure whether there's a language barrier here, Patrick, or you've not had enough coffee drink yet.
Yeah, probably not.
Yeah, I said there's a full suite of APIs here, and it's surrounding the core product. So you can obviously stream and process data, but you can build anything with this capability.
Yeah, definitely. So the key concept of this is to be able. We are working every day to allow our users to integrate easily this workspace in any of your products. So imagine that you have a product, you have a platform, or you have an application, or you have something that you are working in your company, and you need some real-time processing capabilities, and you don't want to deal with all these Kubernetes, Kafka, all the protocols that to send to receive data, these APIs. So the key concept is that we are providing this out of box, and you just need to use this part of this software and integrate it with your software. And the key concept is to be able to provide some real-time capabilities to your product.
Very nice. Very nice. And you said you had another slide, Patrick.
Yes, I have this.
Oh, what magic is this?
So there is another way to send and receive data in our workspace. So
of course, we have the SDK.
Yes, sometimes because this streaming APIs is introducing a bit of latency, or some latency.
How much latency?
I don't know exactly, but more than Kafka directly. Okay. So Kafka is just introducing around 10 milliseconds. This very, very low latency. And sometimes you want to use this low latency because you need very fast response. So you want a system that reacts in less than 50 milliseconds or less than 40 milliseconds. So in that case, and if you know how many devices you are going to send data, imagine that you don't have infinite number of devices like mobile phones. You don't have infinite number of users that is going to connect to your system. You have only one or two. So imagine in the Formula One, we have only two cars. No, so this is a very good example. You don't want to use the API, because in that use case, you have only the two devices or two cars, and you want to send data very fast. And in that case, you can send data to a topic directly using our SDK instead of using the API. So the only restriction here is that you should use one of the language that we are providing now in our SDK. That right now is Python and C#. So there is a limitation. You need to use Python or C#. You should know how many devices you are going to use to send data, because Kafka, as we were saying before, is not good dealing with a lot of connections.
Yeah.
But if you agree with these restrictions, is another way to send data using directly from. I have painted here a washing machine because it could be anything. Yeah. It could be even another system, another computer, another process that is sending data very fast to the workspace as well.
Right. I mean, a washing machine is clearly a bad example because there's lots of washing machines in the world. Probably as many washing machines as mobile phones. But
maybe it's not a good example. Yeah.
We have some developers I know that have machine data. So they have one Linux box in a factory, and the machines write data to that Linux box, and that Linux box is a bridge then in the SDK format to the Quix workspace, and that's because the performance, the sampling rate is very high, correct?
Yes, we are very efficient. So we were trying always to create a SDK very efficient in terms of throughput and latency. So and if you use directly the SDK, you will get the best throughput and latency.
Okay.
So because the
SDK is maximum performance, smaller number of devices, whereas the streaming writer, the trade-off for high number of devices is performance, correct?
Yes, exactly.
Okay. Okay, and when we talk about the SDK here, I mean, that's what are we talking about when we're talking about high performance? Is this is the data, what kind of frequency can we achieve, sampling rate can we achieve?
I think I can say that we were sending around 1 million values per second or something like that in Formula One, and I think that with this SDK you can even do more.
Yeah.
But I don't want to say exact number, but around 1 million values per second.
So we can easily deal with, that's 1,000 kilohertz frequency.
It's well, 10,000 kilohertz is something that we could do definitely, because we were doing it in Formula One in McLaren.
Okay.
And with this SDK, I think that we can even do a bit more.
Wow. Okay, maximum performance. And then back to the APIs, this is much more, probably lower frequency, because humans interacting with a mobile phone is several times a second, or if you're typing fast, or...
Yeah, well, you can achieve a lot of high frequency as well. But because we are quite efficient in terms of how we are sending this telemetry data, so we are not sending one value for each request. So in each request, we are allowing to send a chunk of values. It's depending how you want to divide these chunks. If you are creating more packages, you will have more latency between them, and you will have less speed.
Okay.
But you will have in the output, you have the benefit that the data is going to be more real time. You're going to have less jumps. But it's always a trade-off. Okay, so if you are sending more chunk of data, you're going to have better throughput. But in the consumption of this data, you will see some jumps between each chunk of data. So it's up to you. What is your requirement of your system? If you're creating a game, for instance, you probably want to send small packages because you don't want to see the game jumping in the screen. But if you are not developing a game and there is not a requirement for your system, probably you want to create a bigger chunks of data.
Okay. I understand. And I think also this is a performance quality trade-off because of backfill and things like this, correct?
Yes. Yeah, there is always requirements of each system. You need to analyze what are the requirements of your system or of your real-time capability that you want to provide. And depending on these requirements, you can decide the parameter or the tuning that you're going to do in this when you're using the SDK or the streaming writer API.
Okay, and that's all configurable. The user can choose.
Yes, it's configurable, and yes, in the SDK, it's allowing you to create even buffers or select. I want to send data every 100 milliseconds, or I want to send data every millisecond, or even I want to send data every 10 timestamps, something like that. So it's everything is configurable from our SDK or the streaming API.
Okay, very good. So then the elephant in the room is the streaming writer API. There are some amazing technologies out there. Ably is one of them. It's a whole product. It's a whole business based on providing WebSocket APIs. So why does this Quix streaming writer API exist, and when should you use it, or when should you use Ably's streaming writer API?
Yeah, actually we have a connector with Ably. So It's very compatible, our Steam API and Ably, but I would use Ably if you have a need to have you have users around the world, because they have the ability to have very low latency around the world. And if you have your need is to have very low latency around the world, and if your data is event based, because it's basically event based, the Ably data, I could use Ably. If your data is telemetry data, is regular based, very high frequency data, and is not spread around the world, I would use the Telemetry Writer API.
Okay, so it'll be a simpler decision, but it's really based on the use case of global distribution and whether you're using event or high frequency telemetry data.
Yes, exactly.
Okay, and so you say we have a connector. So basically, a developer could actually integrate Ably into their client device, send it to the Ably API, and then use the Quix connector to get that data into a workspace.
Yeah, it's basically you put so you put a connector. I think that is going to be something like this here.
Yeah,
the Ably connector.
Oh, okay, yeah.
And the Ably connector is basically writing data with the SDK format, and it's going to gather information from Ably platform. Yeah.
It's written in the Quix SDK, so it does the data conversion for you into the very powerful Quix client library.
Yep.
I mean, I've got to ask the community, those of you who are watching, SDK, do we understand what an SDK is? We've got an internal debate at the moment, whether we should continue calling it the SDK, whether we should call it a client library, whether we should call it an engine, whether we should call it a framework or something else. Comments, please, in the section of YouTube. What is this thing? I think we'll call it a client library rather than SDK.
Yeah.
Cool.
Yeah, that's right.
Patrick, at the end of the day, there's no one size fits all. So even other users of Quix, they use like IoT Hub from Azure or from AWS. So I guess there's other use cases about whether you choose Ably or Azure IoT Hub or Quix SDK or Quix Streaming Writer, correct?
Yeah. Well, it's always depending as well if you are already using some technology. I imagine that in my company, I already using Azure, or I'm using what is the name of the Amazon one?
I think that is it not also called Azure IoT?
Azure IoT, yes, and the other is Google Pops Up. So if you're already using these technologies in your company, probably you don't want to change that. We are providing some connectors to allow you to integrate this piece of real-time processing platform in your product in an easy way. So
we're back to the purpose of the APIs. It's all about integration and giving our developers the flexibility to build their best-in-class solution. Correct?
Yes, exactly.
Very nice. Very nice. Do you have any other magical slides in here, Patrick?
No, it's the last one.
No?
No.
That's a massive shame. Well, can you also do me a favor then? Let's go and look at the documentation. Can you flip the screen to a web browser and talk us through maybe how to use some of these APIs?
Yes, let me stop this. So our documentation. So we have here a part of the documentation for the SDK and documentation for the APIs. And these are the 4 APIs that we are talking about. And for instance, if I go to the Streaming Writer API, we have here some how to authenticate the API, how you can provide a token, or how I can get the Swagger, because we are using Swagger to document this API, so you can access easily to Swagger that is looking like this, something like this. Is this is this not this one? So this is the query API, for instance.
Okay.
And we have a Swagger, and you can some examples how to do a request, forming a request.
Request, yeah.
Yeah. So it's explaining as well if you want to use WebSockets instead of HTTP. So we are explaining here a bit how to create this code. We are explaining how to create a stream because our protocol is based on a stream. So you can send data and send infinite streams inside of one topic.
Sorry. What does that mean? A stream? What does that represent in Quix?
A stream is a logical separation of one of your entities in your platform. For instance, imagine that you are a company that you are processing washing machines. No, following the same example. Each washing machine probably is going to be a stream, and you don't need to use different topics for each machine. So we are providing a protocol where you can send all your washing machines through the same topic, but in the reading side, you will be able to process each machine separately.
Patrick, you got to adjust your camera. I just noticed we can only see the top of your head.
Sorry. It's because I was writing before.
Sorry to the Quix folks for denying you the pleasure of Patrick's face for the last 10 minutes.
So this is basically a logical separation of your data, basically.
So basically one stream per client device.
Yeah, and we are using this separation as well to do how it's called when you process a lot of data, you want to be able to scale the process of this data in multiple replicas of your pipeline. And we are using this logical separation to balance or to spread all this load between all the replicas to allow to process infinite number of washing machines in this case.
Right. So it's really it's a user-defined separation, which actually gives you the horizontal scale inside the Quix workspace.
Exactly. Yeah. Because you don't want one data of the same machine go to the different computers,
Yeah. So if you've got two replicas, you want all the data from one machine to go to one of the replicas to make sure it all gets processed together.
Exactly.
Very smart. But then, Patrick, I'm noticing here you've got the SignalR and what else? HTTP. Well, so is this two APIs or is it one?
No, it's the same API, but with different endpoints. So
Can you explain the difference?
So HTTP. So HTTP is a very old technology. Mainly all the languages on any device can send data through HTTP, and is the reason because we're providing HTTP protocol. Because even in a very old machine or a very old computer, you can execute with C++ or with JavaScript and HTTP code. But in the other side, we realized that we could provide a better. Is the same as standard as HTTP, but WebSockets is a bit faster if you want to send telemetry data and send it continuously. So because we don't have the latency of the connection each time that you have in the HTTP. So WebSockets is you are connecting once to the service and you are starting to send in data to the same channel. It's like a socket. So is the reason we are providing these two, because HTTP is more standard for any device. And WebSockets, if your language support it, we are providing this faster way to send data.
Right. So the HTTP API is sort of traditional request response, and therefore it's probably a bit lower performance, I would think.
Yes.
Yeah.
Yes.
WebSockets is just a wormhole, so you can shove a lot of data into the black hole very fast.
Yes. Exactly that. And yeah, you have some examples here. You can try it. You can even have some library items that it's providing this code out of the box if you want to try it as well. And you have as well the documentation for the reading part. That is again WebSockets. In the reading part is always WebSockets because when you are consuming data in real time, you don't want to ask for data. You are not pulling. Give me data, give me data, give me data. So HTTP is something that you ask to a computer for something and you get a response. And it's just one single send and response protocol. But when you are consuming, what you really want is to connect once and say to the guy, give me data when you have it. So if you have data, send me the data. You don't want to ask continuously. You have data? You have data? No, it's just connection and saying, when you have data, send me it back.
Why is that then? So on the streaming writer, to get data to the platform, we've provided both. So you can do the traditional request response HTTP, or you can open up the wormhole and stream with WebSocket.
Yeah.
On the way out, why isn't there a HTTP API? I mean, wouldn't you want to poll the portal and see, is there an update? Is there an update?
Yes, because it's a very inefficient way to consume data in real time. So it's something that is working for historical data, for instance, for the query API. But because it's just once, you are asking, give me the information that you have between this date, this timestamp to this timestamp, and it's just one request.
Yeah.
But to ask to the service very frequent, give me data, give me data, give me data, even if you don't know if there is new data, it's not a good design. So we don't even providing this HTTP because it's nonsense.
All right. So the design paradigm actually, so this is called a streaming reader, which implies the client is reading, but it's actually it's more of a push mechanism. It's more like Quix is pushing data constantly down to the client.
Yeah, exactly that. Yeah, okay. It's creating a connection and is asking. So you are asking to the service, give me data of this parameter when you have it, and if you don't have data, don't bother me.
Don't give me anything. Oh, okay, so it is actually the client is opening up the request, but it's just open.
Yes.
Cool, and it's these two, streaming writer and the streaming reader, which give you this nice round trip potential. So you can send data from the client to the cloud, get it processed. I'm Uber and I want to build my my usage-based pricing backend, and then I can basically get the data back to the client as well in a small amount of time.
Yeah.
Very cool. You fancy being put under a lot of pressure, Patrick?
No.
I'm going to ask you to live code, so write some data to Quix, but no, maybe that's just too much. Maybe we should leave that for next session. What do you think?
Maybe next session. Let me prepare it a bit.
I would say Thomas would do it, Patrick. You know that, don't you? If Thomas were here, he would do it.
Of course. Thomas is the reason because he's the CTO.
Well, it's just because maybe he's a little bit crazy. But
yes.
He's also got used to dealing with the pressure.
Yeah, it's good. Yeah, he's good dealing with pressure.
Yeah. Oh, very good, Patrico. So I think unless you've got anything else major to say about the APIs, maybe we're coming to the end of the Mike and Patrick show version 2.
Yeah, I think that we have explained quite well the APIs we are providing to use with Quix. And if people have some doubt or they're curious about some details, well, they can reach me. So they can send me a message.
How can they reach you?
Well, I can provide in the comments my email and the Slack channel. We have a Slack channel that is public, the stream channel, and we are going to put the link as well in the video. Okay. And we are available always there, 24 hours probably, 24/7 hours.
24/7. That's because you work 24/7.
Yeah, mainly. Yeah. Me and Peter, we are covering the whole day.
The whole day. I know you are. pulling like mad. So guys, I think we're at the end of today's show. Thank you everybody for joining in. If you've got any questions about our APIs, please drop into the Slack channel. There's a link there in the footer. If you've got some thoughts about whether we should be calling our SDK a client library or maybe give it a, I don't know, a boy's name or a girl's name, then let us know. Otherwise, thank you very much for joining. Patrico, thank you very much. It's a pleasure as usual. And we'll see you